Okay. Well, hello everybody. Welcome to our discussion on Yarn. We're going to go ahead and get started. So today, quickly, my name is George Corjado. I'm the CTO and one of the founders of Redpoint. And we're going to talk about Yarn today. Yarn is one of the things that we think is a real important evolution in the maturation of Hadoop and the ecosystem. And I want to tell you a little bit about the impact we believe it's going to have and how we've used it to solve some of the challenges. Because at the end of the day, we all know, everybody here knows exactly why we're here, why Hadoop is an important technology, what the value of Hadoop is. But for it to really become mainstream, a number of challenges have to be overcome. So first thing I want to do is talk a little bit about just some of the basic fundamentals. As you all know, obviously, Hadoop brings some real important benefits to data processing. Obviously, lower cost scaling. That's a really important aspect of Hadoop. It's really where it gained its fame, the ability to scale on commodity hardware, do very large-scale parallelized processing. The other part that is near and dear to me as an analyst, because I started in this business as a statistician, is that you don't need to structure the data. If you're working in Teradata and you want to capture a new source of data, bring it in, what do you have to do? You have to get the data model committee to sit down and figure out what table to put it in, what format to put it in, how to link it, etc. And Hadoop takes all that away, so it really gives you a level of agility in terms of being able to capture new data, be creative, and experiment and find where those real insights can come from. So it really facilitates data capture. But the bottom line is that Hadoop is a relatively new technology, and with new technologies come immature ecosystems, and that's what right now we're starting to address with things like Yarn. So all of you know Hadoop and Hadoop 1. You'll take a look over here. Hadoop 1, basically think of MapReduce as the only application that ran on Hadoop 1. And MapReduce was talking to, and if you will, I know HDFS is software, but let's think of that as just a machine, right? And so MapReduce was talking directly to the machine. And it was the only application that would talk to the machine. So you had other or abstracted ways of generating MapReduce, but at the end of the day, it was still all MapReduce. With Hadoop 2, a very important thing happened. Yarn was released, and Yarn, if you look at this quote off of the Hortonworks website, it says, Yarn supersedes the classic Apache data processing approach of MapReduce. And really, what's really important is Yarn is essentially a data operating system, and notice what happens. MapReduce now becomes one of the applications, and there's room for others. And that's really the important piece, because no longer, by Yarn being deployed, no longer do you have to rely on MapReduce. And not that MapReduce is bad, but at the end of the day, MapReduce has essentially two words in its vocabulary: map and reduce. And you're going to have to construct and link all these things together in one way or another to accomplish your data processing jobs. But some data processing problems are very, very complicated, and it's just not enough to have that limited vocabulary. So what this enabled was for Redpoint to come in and become one of these peer applications to MapReduce. We talk directly to Yarn. The binaries that come out of our application go directly into the operating system, the data operating system, and then operate natively inside of HDFS without ever having to encounter MapReduce or any of its limitations. And the way I like to think about it is, instead of having a vocabulary of 2 words, now you have a vocabulary of hundreds of words to be able to compose those very robust and complex data processing problems that you're all going to encounter. And where the really big impact comes is in productivity, people productivity. Now, that's what we did. Pretty cool. Why is it important? The fact is that you talk to analysts, you talk to pretty much anybody who's been around this space a little while, and they'll tell you that there's some real challenges to adoption of Hadoop and the associated technologies. One of those, and perhaps the biggest one, is the skills gap. The fact is that companies like Teradata are out there acquiring other companies just to get the MapReduce programmers. It's really, really hard to find people who are skilled in MapReduce. If you train them, then instantly you will not be able to afford them because now they become a hot commodity and they're going to move to Silicon Valley, Austin, or Boston. And if you're a mid-range bank out in Milwaukee, forget it. You're not going to get a MapReduce programmer. And so, you know, if you think about mainstream adoption, the fact is that why shouldn't that mid-range bank in Milwaukee get to use Hadoop and benefit from Hadoop like everybody else, right? So tools have to be in place to let them access it. And what I think is the real hurdle, not the hurdle, the hallmark of getting there, the benchmark of knowing that we've gotten there is when we can take a DBA, one of the army of DBAs at every organization, and in 1 week train them to work seamlessly on Hadoop and on other databases. When Hadoop stops being a special topic, that's when it becomes a mainstream application, and that benchmark is not something that I chose accidentally. So anyway, the second part is maturity and governance. Large IT organizations are not going to adopt this technology until they can apply their governance procedures, their data quality procedures to this data. And if you think about it, Hadoop, A, often is a skunkworks project, so most of that governance doesn't happen on it. And B, a lot of the data that gets thrown into Hadoop is external to the organization, so it's the least reliable data the organization will ever touch. And so you need data quality, you need data governance in order to make sure that the analytics you derive are the best possible. And then from an analyst perspective, there's an interesting little challenge. As I said, I was a statistician. I came into this world from that angle. And one of the things that statisticians and data scientists do is that they spend a lot of time structuring data because algorithms, like a regression algorithm, for example, they're very picky. They want the data in a particular structure in order to be processed. Well, remember on the first slide, I talked about how you don't have to structure data in Hadoop, you just dump it in there. Well, now it's up to the analysts or the data scientists to structure the data. And a lot of data scientists and analysts don't want to have anything to do with having to necessarily code that process of restructuring the data because that's the grunt work. For a statistician, the fun part of the process is putting it in the algorithm, testing, and trying to learn from that, right? So that problem has to be addressed as well. We get a lot of statisticians who say we want no part of having to code that stuff, right? So here's some of the challenges. And what we've done at Redpoint is that we have a very mature, very broad and sophisticated data management platform. It is the first data quality, it's the first pure yarn data quality ETL, a master key management application. And actually, we were one of the first 17 companies or technologies to be certified by Hortonworks when Hadoop or Yarn went GA last October. And actually, out of those first 17, we're only one of 2 pure Yarn applications. And this is important because if you're not a pure Yarn application, that means that MapReduce is still knocking around in there and creating some limitations in the processing framework. Here's what's really important, though. Prior, and in terms of this concept of maturity of the application, we've been in the market for a long, long time, and I know a lot of you have heard about or seen TES, and you know there's some real interesting things coming out of TES, but it's still very young. Data quality is a very complicated set of processes, and it doesn't get built overnight. And what we've been doing is we've been in this business for a long time, optimizing how we process data, building very, very broad functionality. And as a matter of fact, prior to the whole Hadoop initiative, we were already ranked #1 by Gartner in dealing with customer data, in processing speed, in match quality. And matching and linkage is what we think makes data useful and ask statisticians how they feel about being able to bring and link all the data together. And we were ranked #1 in ease of use. And now we have brought that complete application, 100% of the functionality works identically within structured databases and within Hadoop, natively against the HDFS. So when we talk about that, what is the functional footprint of Redpoint? Like I said, we do ETL and ELT. In the case of Hadoop, we do it entirely inside the HDFS and actually leverage the HDFS for the processing power and the scalability. Data quality, as I mentioned, these are complex data processes, but it is essential for getting good results out of your analytics. At the end of the day, and as a statistician, I will tell you that it's better to not have data so that I can't build a model than build a model off of bad data, because I'm more likely to make a big investment in the wrong decision if I have a model built on bad data. So data quality is a really critical element of getting good analytics out of your data. Matching and persistent key matching, this is what brings all that linkage together, gives you complete views of people, of products, of devices. We're doing a lot of work. We have a lot of geocoding capabilities built in here. We're working a lot with device data, their geolocation, how they relate, where they appear, and how do you link these bits of information together so that, and do it probabilistically. Not necessarily, if you've got a key, easy to link data. If you don't have a key, it's a real challenge. And we attack it 3 different ways. We've got our heuristic, probabilistic, and machine learning algorithms to link the data across sources and determine that, say, George Corrado, who lives in Wayland, happens to be GRC27 in Twitter, G27C at Yahoo, and so on and so forth. So this ability to link the data is really important. Obviously, data capture is critical. We access data from every source, every format, every structure, every cadence, every lack of structure. There is no excuse, and it takes literally minutes to deploy, build and deploy web services, no coding required. And there's a very robust automation layer, which lets lots of your processes be lights-out processes. So what does that really mean? So we love our application. What does that really mean in the world or in the ecosystem of Hadoop? This is one of the Hortonworks reference architectures. You may recognize it from their website. And what you see here, as is typical of an immature or a nascent, let me not be judgmental, but a nascent technology ecosystem, you see lots of point technologies. Lots of them have immature interfaces. And what you've got to deal with is a lot of coding in those interfaces, right? Some of these, you're trying to read data, and it's like you were trying to read a data file with writing C code as opposed to just importing the data through some type of database engine. So it's at that level. And what we bring to the circus is a full suite of functionality that covers and simplifies the environment. So this is one step closer to this idea of being able to get your DBA trained across all of the technologies and deployed so that they can be working on Hadoop without necessarily having a bunch of very specialized skills. So anyway, so just to recap, in Hadoop 1, what did you have to do? You had to either write code, or there was actually, we have a lot of clients that were actually moving data outside of HDFS and Hadoop to do certain processes that they couldn't do in there, and then running it back in. That's a very expensive process. And in our interface, what you're going to do is all visual, all drag and drop, and it works exactly the same way in Hadoop or in traditional data. Now, there's a couple of very important architectural elements to this and how this works, and this is really key. And I mentioned some of this because this really goes to the heart of the marketing noise and buzz that you get out there, and some of the questions you should be asking and challenges you should be posing to some of the vendors out there. Because number one, we are very delicate and very light on the cluster. We have a 0 footprint install. Fact is that we actually don't install on the cluster at all. We install our application outside the cluster. You configure your jobs outside the cluster. the executables, I'm sorry, the binaries are generated outside the cluster, and then they're handed off to Yarn. Yarn is the one that distributes them across the nodes. The data is processed, and those binaries evaporate once the processing is done, leaving the cluster completely pristine. All right? So this is a really important part of why it's important to be pure Yarn, and being certain that you're not just consuming a bunch of cluster resources, because a lot of applications will actually load up the cluster with a lot of code. They actually will pull the data out of HDFS, run it inside the cluster technically, and then push the data back down into HDFS. So you're really not really using HDFS or the power of HDFS in any way. So this is an important architectural element that you should challenge people on. The other aspect of it is this is the interface of the application, and you see there's no coding here. It's a palette of hundreds of different types of functions, features, processes. You can build macros, etc. And what I want you to take special note of is these three icons right there in the middle, because when you go and work in the Hadoop world, it's exactly the same features, same functionality, same icons. All you're doing is you're dropping them inside of what we call a parallel section that says, instead of running this locally in memory, because we are an in-memory processing application, run this out in my Hadoop cluster. And if you have to do partitioning, or what you might otherwise know as shuffling data, moving it around, we actually, because in a lot of processes, you've got to compare records, right? So we do that with drop-down menus. You can partition the data however you want, group the records, etc. We make it really easy. There's no reason this has to be hard. And in terms of configuring for Hadoop, it's no more than finding the name node and letting the machine know what version of Hadoop you're dealing with. And it's just that simple. So again, one step closer to letting your DBA be your Hadoop expert. Now, what do we have here? This is a simple project that comes with most Hadoop distributions. It's the Gutenberg project. It's just a sample project so that you can knock around a little bit with your newly installed cluster. And it's a word count problem. 30,000 little files. You count up the words. You look at how many times each word occurs. And what we did is we took it out of the box. It doesn't run very well, so we spent about 6 hours kind of optimizing, cleaning up the code, doing a number of things. And we got about 6 hours of development. It ran about 6 minutes in a dinky little i5 10-node cluster of Best Buy desktop discards, right? I mean, it's just kind of the leftover desktop machines. We put a little dinky cluster together. It ran in about 6 minutes, not bad. We then rewrote this in Pig, obviously a somewhat more abstracted environment. We had to build a UDF. It took us about 3 hours, and it ran in about 15 minutes. In our application, this is what it looked like. It took us 15 minutes to write 0 lines of code, and it ran in 3. So not only did the application run faster, it actually, the really significant impact is not necessarily just on processing speed, but it's on developer productivity, right? This can be done by a DBA. These cannot necessarily be done by a DBA. And so this is where the real impact is felt, is on sheer productivity and scalability, not of the technology, but of your workforce, of the people that are going to be accessing the technology. I listened to some folks from Disney some years back who were doing a little skunkworks project with Hadoop, and actually a number of big data technologies, and they started with 7 people. They ramped up to about 47. They had every kind of technology. Everything in the environment was coded by the team. And you can imagine the size of a company like Disney and the number of analysts and DBAs that are in the organization. And it was really interesting because the guy who was running the Hadoop project was saying, he goes, they were really intrigued by the data, but the team could not get to the data. They didn't have the tools or the skills to get to that, right? And until you really empower the rest of the organization and the army of employees that you already have and resources that you already have to access this, it's going to be really hard because it's going to be very specialized and difficult. And at the end of the day, code-based solutions are notoriously inconsistent. They're only as good as the coder. They're only as good as the people that write them. And then when they leave, what do you do with that, right? So, excuse me, we think Redpoint is a really important part of a modern data architecture. The key thing here is that from one implementation of Redpoint, you can actually access all of your data processing with across structured data, traditional databases, or across Hadoop. And we can become that broker, that intermediary, that before any of the data comes in, it runs through a number of integration processes, data quality processes. I can't hit that hard enough. The analysts in the room will appreciate the importance of just sheer data quality, making sure the data is structured correctly, making sure that records are complete, that elements are complete, that the data is parsed correctly and put into the algorithms correctly. Really critical. And then there's a whole host of other day-to-day activities, all the ETL, ELT, the merge purging, householding, partitioning, the automated discovery of parsing rules. One of the things that we do that's really interesting is that, for certain types of data, you know exactly what to expect and how to parse it, right? And parsing is this very kind of low-level activity, but critically important to tokenizing data and then being able to match it effectively across data sources. And I've talked a little bit about our match capabilities and so on. But parsing is really the dirty little secret under there. How do you parse data? How do you discover the parsing rules? And how do you create them quickly and efficiently? And we have some very, very easy to use and sophisticated parsing rules where we profile the data, we look for patterns, we give you very, very quick statistics on the frequency of patterns, the structures of patterns, and then automatically from those, almost as in a process of elimination, develop the parsing rules for each one of those patterns. And you can quickly take data that you've never seen before, figure out very, very quickly what those parsing conditions are, and then build the rules to automate the whole process. And again, no coding required. And so these are the kinds of problems that you encounter when you're really expanding into a world of unknown data or of unfamiliar data, I should say. Another example of the kind of thing we're doing, we're working with a company called WGBH. They're a public television station out of Boston. They're actually one of the biggest producers of public television content as well. They have a number of initiatives running on Hadoop, and I mentioned them specifically because they are a nonprofit, and I don't know how many of you work with nonprofits, but they don't pay real well. You're supposed to get, some of the benefit is just knowing that you're doing good, right? And so that's great, but people have to live, right? But the fact is that they're very ambitious, and they're always trying to do really interesting things. One of the things where they started off is they wanted to do social listening, and in the context of providing better customer service to their donors. Because if you think CBS is concerned about viewer reactions, it's nothing compared to what a company like WGBH, who depends on donations from those viewers, cares, or how much they care about viewer reactions. So they're obsessed with it. And so we went through and we built this cluster for them. We started taking Twitter data, pouring it in across lots of different hashtags and keywords and handles and so on. And the fact is, now what happens? Okay, we pulled all this data, but their people are trained in our application. No great skills there. I mean, they're smart people. They're DBA skills. They're working across Hadoop and the structured data seamlessly. And what they were doing, and the reason they wanted to actually do this is because what they really care about is those high-value donors. And when a high-value donor says something negative about them on Twitter, they want to have a phone call out to that person within 15 minutes. So, what are the elements that are needed for something like that? Number one, we've got to capture the data and do it in a timely way. Number two, we've got to do identity resolution. We've got to be able to tell who that person is, and that this person is connected to this person over here in this other database who is a high-value donor. How do I link those two? Number three, we've got to do sentiment analysis on the data so that we know it's a negative tweet. And number four, we've got to automate the process of taking that tweet, linking it to your contact record, sending it out to Salesforce for an immediate callback, and doing it completely in an automated fashion without human intervention, okay? So if you were going to do that with traditional, in quotes, traditional Hadoop tools from the ecosystem, you've got 15 different applications you're going to use one way or another to accomplish that process. In the WGBH world, it's one application, and it's being operated by the DBAs. Okay? The other example that I've got from GBH, which is really interesting, and it goes to the whole idea of being able to coalesce lots of different types of data, is that they're in the process of developing a second screen application so that while you're watching Downton Abbey, you can rate it up, rate it down, say, I like this guy, don't like this guy, you know, I like the show, don't like the show, etc. I can tweet and interact with other viewers. I can even do micro donations through my mobile application. All wonderful. Again, they are obsessed with what people are thinking about their shows. So not only are they collecting all this Twitter data, application data, device data, location data, etc., they're also dumping in the scripts, the timelines of the actual shows, all of the scheduling information that surrounds the shows. And they're doing massive analysis across all these different data elements. From a production perspective, the producers love being able to line up people's reactions simultaneous to the timeline of the show and watch how people are responding to different elements in the storyline. And all of this is being done in one big Hadoop environment. The other thing is that, you know, obviously they want to know, you know, there's the nuances, right? You can have a bad character or a good character be just as effective in a movie. It might make you feel really, you know, angry, or might make you feel really wonderful. But at the end of the day, it's engagement. It's part of the drama of the show. So there's lots of nuances. It's not just good and bad like you see in the political debates. It's good, but I hate this guy, bad, you know, indifferent, and this person's kind of boring. You know, there's all these dimensions to this analysis, and all of that is being captured inside of the Hadoop cluster, and again, being run by the resources that are already in the organization. So that's the goal, that's the objective, that's the threshold that I think we're trying to achieve, is the ability to democratize Hadoop and get it out to all these other organizations that don't happen to be located in Boston, Austin, or Silicon Valley, right? So who should care about all this? We find a lot of organizations are doing things like, you know, like WGBH. They're dipping their toe in the whole big data analytics pool. And it's really hard to get started. We talk to a lot of organizations that are doing things and asking us, they say, well, you know, we think there's going to be great benefit to this, but we're nervous. We don't have access to the resources. We don't want to necessarily invest all this money in the technology. We're trying to figure out a way to get started. Well, again, getting started is all about being able to mobilize with the team you've got and figure out how to get started, right? So a Hadoop deployment in the cloud with an application like this, where we can take a DBA and train them in a week to operate inside of this environment, is really critical to making it easy, because that's, again, what will then drive adoption and drive the maturation of the overall Hadoop ecosystem. Other companies are already investing heavily in big data analytics and are running into the same skills problem. I was actually talking to a Wall Street Journal reporter yesterday, and she was telling me that she's hearing more and more about big data projects, big data analytics projects that have been heavily invested, and they're stuck. or they're failing because they're losing the resources. One of the things you can't help at this point is that the completely inordinate expectations that are set about the miracles of Hadoop. So that's a different kind of problem. But the ability to take these projects and now move them ahead and do it in a simple fashion is really, really critical. So those are the kinds of companies that are also should really be paying attention to this. Other companies, like very large enterprise organizations, what are they doing? They've got these Teradata implementations that aren't going anywhere. They use them, they're adopted by the whole organization. However, they don't want to necessarily grow it because we all know how expensive Teradata is. So a lot of big enterprise organizations are just doing what you might think of as operational offloading, right? Move my data out of Teradata and put it someplace else. Or do my data warehouse pre-processing over in Hadoop so that I don't have to buy more Teradata. So these are the kinds of companies that I think should really be paying attention to this type of evolution. And frankly, I think one of the things that's been a little surprising to me is that Yarn hasn't become more of a hot topic in the Hadoop world. I think it's something that's going to change over the next 12 months because it is the direct access into Hadoop from large enterprise technologies. So I think it will become much more of a relevant component of the environment. Finally, the other group that I think really should be paying attention to this is analysts. Analysts have to structure the data, analysts have to prepare the data for analytics, and analysts at the end of the day have their name signed up on the quality of that model that they've built. And data quality is critical to achieving that level of quality on the model that they've built. So I think those are the key companies that should really think about this. So ultimately, what are the benefits here? Let me just quickly summarize. Overcome the skill gaps. That's an area where I think everybody should be focusing. How do you make it easy and accessible to everyone, right? It's, one of the funny things about the open source community is that, it's all about democratization and, giving access to all. But if it's all code-based, it's really hard to get access to all. And so we've got to be able to accelerate that process. No compromise on quality. And again, this is one of the challenge questions for the other vendors. How much of your functionality works identically outside of Hadoop as it does inside of Hadoop? Ours, 100%, really critical. The other element is everything's done inside of Hadoop, so all the processing that we do on Hadoop processes directly inside of it. So no need for extra staging or storage. And ultimately, we can work across any data environment. As I mentioned earlier, we think that there's a role in the modern data architecture for something like Redpoint that sits there and becomes the filter across all of those different sources of data. So what I'd like to invite you to do is to come visit us in booth P13. We're out there, big booth, lots of people come talk to us. We're happy to talk to you about what we do, and really, even if you're not interested necessarily in the functionality that we're doing, how to structure your projects, how to get started, how to think about the projects that you're doing. Because look, at the end of the day, one of the things, I worked at Accenture for many years, and one of the things that's the key to successful projects is setting correct expectations. And one of the things that I think this world of Hadoop suffers from, and big data suffers from, is the unrealistic expectations that have been created by all of the buzz and the hype around the technologies. For those of you that follow Gartner, you'll know that they've got the Gartner hype cycle, and big data is quickly going into the trough of unmet expectations, right? But that's okay. That's part of the process. But how do you make that drop into that trough as smooth as possible without really hurting the opportunity to actually get some of these projects off the ground? So we're happy to talk to you about that because we've thought a lot about that. And, and hopefully we can help you. We also have a number of interesting resources out there for you to take with you, documents, reports, analysis that we've done, and we've got all the brainiacs from our organization that built the software there to answer any and all questions. So with that, I'm going to go ahead and stop and see if there are questions out in the audience. There's a microphone out here in the middle, and would be happy to answer any questions or discuss any topics you would like. Yes, sir. Would you mind? Sorry. The AV team will slap my hand.
I just wanted to know how Yarn can help enhance the search capability using your tool.
How Yarn can help what?
Enhance the search capability across the cluster or clusters.
Sure. So Yarn itself is an access method for the technology, and search is all about parsing data correctly and organizing it in such a way that your search engine. So what Yarn does in that respect for us is allows us to do a lot of that data parsing very effectively and do it inside of the cluster. So it doesn't directly do that. Think of Yarn as a data operating system, right?
Right. So another question I have is that in your product, how do you manage the input splits, or do you have a concept of input splits? If it does, I mean, since you are directly going into the, you're bypassing the map reduce per se, but you still have to organize your input splits in some fashion. So I'm just wanted to see.
So there's a couple of ways. Again, the entire application is all drag and drop, so you can manage that at a very granular level within the actual tools. You remember the icons that were up there? Inside the tool, you can actually define how the data is being input, but then there's also the various partitioning methodologies that we have. We call it partitioning, but it is about, grouping data. How do you do the inputs? Where do you put them, et cetera? We've got a lot of really easy functionality, and if you stop by, we'd be happy to show that to you.
Okay, thanks.
Okay? Any other questions? Comments, expressions of disgust, dismay? Yeah, sure, if you don't mind, sorry. Yeah, they're recording the session, so.
The model that you discussed, where it's a zero footprint install until you actually go run a job, at which point it sends it out and works, sounds intriguing. And but in my company, no one's probably going to be working with Hadoop unless they are a coder. So the no code point doesn't mean quite as much to me. If I could create a job in that UI though, and then have access for my application to say, hey, go run this job I did, created in Redpoint, and then store the results somewhere that I can get to, that would make it intriguing to me. Is that something can I access this from code, or does it have to be from a UI?
Absolutely, you can access it from code. There are various interfaces to our application. Obviously, the big aha is the fact that we don't have to necessarily, but lots of our power users absolutely use code and the coding interface to get to the applications. Further, the jobs themselves are nothing more than little XML files that actually have all the commands in them. So you can absolutely get to the application, to the jobs, have them all stored. You can even move the jobs out and put them into your source control, and then pull them in and operate from a coding interface.
Great, thank you very much.
Yeah, and come on by. Like I said, the chief architect and our chief data scientists are at the booth, and they can talk to you about that. Anybody else? Any other questions? Don't let the microphone intimidate you. If you want to ask from your seat, feel free. Anything else? All right, well, we're phoning one in now. All right, well, listen, thank you very much. Thanks for attending. Hope you enjoy the conference, and appreciate you coming by.